Today we'll be talking about the AirAsia ticketing system. This project has been put together by myself, Tate, and Amaya, um, and we've been able to use Python to create the bare bones structure of a ticketing system app. Over the course of this presentation, we'll talk about ethics and critical thinking, the analysis and design that went into this program, the infrastructure, the development process, the business loop or the business logic implementation, various systems and features, and then we'll perform a little demo of how the application works. To kind of get us started, we want to think about the main problems that we were trying to solve and how we tried to solve them. So, put simply, AirAsia needed a centralized system to efficiently manage flight bookings, airports, aircraft's employees, customers, and ticket sales. So, there's all these different data points, and we needed to be able to uh, have everything play together nicely in one centralized program. Our objectives were to automate the process, reduce errors, improve what would be operations or what would customer experience look like, and then provide some admin controls on the whole process.
Thank you, Zach. When designing the system, we focused on both ethics and responsibility for a good system design. Customer data such as names, date of birth, and citizenship is securely stored and accessed only through the application. We also implemented an transparent price modeling where ticketing prices are calculated dynamically based on flight duration, aircraft type, and timing. The system prevents overbooking by checking seat availability before confirming a booking. Validation rules help maintain data integrity by ensuring all records and relationships are valid. Next, please. In the first stage, we designed the database structure for airline ticketing system. We identified the main entities such as customer, airport, aircraft, flights, tickets, employees, and flight crew. So each entity contains key attributes, and we defined relationship between them using primary and foreign keys. This design ensures the system maintains data integrity and supports efficient booking and flight management. Next slide, please. Here we are seeing after the design phase, we implemented the system infrastructure. We created base classes to manage data, base connection, and reusable CRUD operations. The SQLite database includes 7 tables with proper primary and foreign key relationships. We also implemented CSV import functionality to populate the database with simple data and used an object-oriented programming design with separate Python classes for each entity, making the systems modular and easier to maintain. Next slide, please. Next, over to Tate.
Thanks, Amaya. So part of the business logic implementation, we wanted to make sure that you could basically create and update, delete, redirect the information. This included the classes of the customer, the flight, the airport, the ticket, the employees, etc. And that was just to manage the database operations and application logic. So each class handles CRUD operations, which is create, read, update, delete for its corresponding table. So you can modify any of our 7 tables in any way we need to fit the business needs. So this structure keeps the database access and business logic organized and modular. And it also separates the logic by entity. It becomes easier to maintain, debug, and extend the application in the case of new employees, new customers, anything that would possibly change. So the changes made to one model have minimal impact on the other components of the system, which helps keep the bugs from popping up that could crash the system. So the business rules implemented was direct flights only. So we did not go into the extent of multi-point flights where you have layovers. We also did individual bookings, so it's not group books. Each passenger must create a separate ticket. Capacity management, we actually researched the different types of planes and flights we would use and put in their capacities so we don't have overbooking. And then the data integrity, making sure our foreign key constraints ensure valid relationships between the customer's flights and tickets. So some of the system features and user workflows. So the customer features, they can search for available flights by departure and destination airports. They can book tickets for direct flights and store booking details in the database, and they can cancel previously booked tickets or reschedules when required. The pricing engine, we implemented a dynamic pricing function that calculates ticket prices based on factors such as flight duration, aircraft type, peak hours, and weekends. So that way it's more modular and the pricing, and it's not just a static price that changes based on when they want to fly. The employee features, we can manage the employee records, including the pilots, the flight attendants, and staff, assign employees to flights through the flight crew relationship, and that just helps us make sure we have enough employees for the flights and we're not double booking employees. For flight management, we can maintain flight schedules, including aircraft, the departure time, the gates, and duration, and also track passengers and crew members associated with each flight. So the user interface and integration, we have an interactive menu implementing a menu-driven interface that allows users to perform operations such as managing customers, flights, employees, and ticket booking. We have system integration connecting the user interface with the SQLite database and business logic classes to execute CRUD operations. We put in error handling so that way the system doesn't just crash if something unexpected is entered. We have a demonstration that we will go into next to kind of show how everything works. And then Zach had some information on the Streamlight that he also worked on.
Yeah, so we took a little bit of time and we tried to explore additional Python modules that are available to us to improve the UI aspect of our application. We explored the Streamlight module, and we were able to perform some of the functions of the app that we wanted. However, we were not able to develop everything quite like we wanted. So our demo will take place primarily in the terminal, but we just want to highlight that we did take the opportunity to look at other potential solutions. So let's move on to the demo now, and Amaya will share that.
This is the user interface that we have. We have the distinct categories like operations, reports, and system utilities. Let's first see in the operations menu what we have is airport, aircraft, employee, customer, flight, and ticket management menu. Let's see that first what we need to do is we need to import the data from the CSV file. Let's first import. Yes, all the data are successfully imported, and the main part over here is flight ticketing management. So as of now, we don't have any tickets, so we will fetch ticket, fetch flights. No, we will purchase tickets first, but we can do that as well. Such tickets, we don't have any tickets. But such ticket number, customer name, or flight ID. We don't have, so let's put a random name. Let's take my name. No tickets found. Okay. And next such flight, customer wants to such flight, then only we can book the tickets. So let's get the flight from Delhi to location, say Bangkok. It is optional, so it will show all the flights that AirAsia operates from Delhi to Bangkok. There are 2 flights on 29. So these are the tickets. Next, go to purchase flight. Again, if anyone is coming for purchasing ticket here, so to see the tickets. So what are the flight options? Let's do the same thing as above. This was search like available flights to Delhi to Bangkok. Let's put Delhi first. Origin station, destination. Let's leave it blank. Let's see what it says. Departure time optional. Yes. We have all these Delhi bound flights. Originating from Delhi. Going to see, you can see this 81 and 83 are popping up here as well. So let's book flight number 81. Okay. Book flight number 81. That is flying at 6:45 Delhi to Bangkok. Okay. Now, for which customer you want to book the tickets? Let's see. My name is here on the top. Let's opt for customer 1. It is showing the ticket price is $648.75. Be willing to pay that much? Yes, of course. Ticket purchase successfully. Ticket booked successfully. Okay. So let's see if we have the same ticket in the system. Let's go back to the main menu. View all tickets. Let's hit 1. Yes, we have successfully booked our ticket, and the ticket shows in the database is purchased. Yes. Now let's go back to update the ticket. Yes. So we have only 1 ticket available, so that's the reason it is showing 1. Enter ticket number. Yes, 1. Select ticket. Yeah. What would you like to do? Cancel, refund, rebook, or to alternate flight? Let's do the rebook to alternate flight. Yes. New origin airport code. Same Delhi. We were flying to Bangkok. We will now new destination Singapore. End date. Yes. These are the Delhi bound flights to Singapore. We are canceling the Bangkok flight and now putting it to Singapore. Yeah. Which flight option? Let's take flight number 1. Sorry. The fare difference is $648 and new ticket price is $654. Additional fare to collect the fare difference. I need to pay $5.25 more. Yes. Am I willing to pay? Yes. Ticket deleted successfully. Ticket purchased successfully. Alternate flight booked successfully as well. Continue. Let's see the tickets. Yes. Earlier I was booked in Delhi to Bangkok flight. Now I have been booked to Delhi to Singapore flight. But what if I don't want to travel? Let's cancel the ticket. Ticket number to cancel. Ticket number is 2. Okay. 2. Ticket cancellation completed successfully. Let's see if we have any more tickets available. Nothing. Likewise, we can book the tickets, cancel the tickets, update the tickets. If we schedule the tickets as well to earlier dates or any options we have.